So by 2026, your home won't just be, consuming power. It's actually going to be generating something like over 17,000 data points a year.
Right. Which is a massive jump.
Yeah, and it'll be trading electricity on the national grid, dynamically shifting its own load while you sleep. I mean, we are hurtling toward this hyper-connected, real-time energy market.
You really are.
But the wild thing is, the legacy billing systems meant to track all this, process and actually make sense of these microtransactions, they are basically teetering on the brink of absolute collapse.
Yeah, because the underlying architecture of the energy sector was, well, it was simply never built for this reality.
Right.
I mean, we're trying to run what is essentially a high-frequency trading platform on infrastructure that was designed to process, a single static invoice once a month.
Wow, yeah, that's quite the disconnect.
It really is. The machinery that makes your energy consumption readable and billable is undergoing this seismic, forced evolution.
Exactly. And that's what we're diving deep into today. We've got this fascinating document that really outlines the frontline reality of this evolution.
Yeah, the Saaniya Qaiser piece.
Right. It's titled Understanding MHHS, Why Salesforce Matters in the UK's Energy Transformation. And for some context, Saaniya is a 13-time certified Salesforce developer.
Which is no small feat.
No, not at all.
Yeah.
She published this in the UK Salesforce Consultants and Contractors community on LinkedIn. And she basically maps out this crazy collision between rigid regulatory mandates and, well, data architecture.
Yeah.
So, okay, let's unpack this. The UK's energy sector is in the final countdown of a total operational overhaul. We're shifting away from that old static historical load profiling.
Moving to market-wide half-hourly settlement, or MHHS.
Right, MHHS.
Yeah.
And as her technical breakdown makes super clear, this isn't just like a routine IT upgrade. It's a fundamental rewiring of how customer data is structured.
Absolutely. And, to appreciate the scale of what she's detailing, you really have to look at the architectural failure of the current system, the estimated annual consumption, or EAC model.
The dreaded estimated bill.
Exactly. I mean, we don't need to retread the absolute basics of how an estimated bill works, but we do need to examine why that static mathematical model is, well, it's become actively hostile to a modern grid.
How so? Like, what changed?
Well, historically, energy demand was just a flat, predictable curve. Power flowed one way, right? From large centralized plants down to you, the consumer.
Right, very linear.
Yeah. So a single annual consumption figure, averaged out over 12 months, was statistically reliable enough for suppliers to just go buy power on the wholesale market.
Gotcha. But I guess that statistical reliability completely shatters the moment you introduce distributed energy resources.
It completely shatters.
I mean, I was thinking about it like this. It's like paying for your monthly groceries based on exactly what you ate last year.
That's a great way to put it.
Right? Just evenly divided, completely ignoring the fact that maybe you just bought an electric vehicle that consumes massive power, or you installed rooftop solar panels.
Right, turning your house into a mini farm trying to sell tomatoes back to the supermarket.
Exactly. You're being billed based on this ghost of past consumption, while the physical reality of the grid is dealing with these volatile two-way power flows.
Yeah, and if we connect this to the bigger picture, the EAC model actually penalizes grid-friendly behavior.
Wait, really? It penalizes it.
Oh, absolutely. The entire point of a modern energy strategy is load shifting.
Okay.
The grid operator desperately needs you to charge that EV at, say, 2:00 a.m. when wind generation is high and demand is low.
Right, that makes sense.
But if your billing system relies on an annualized average, you have zero financial incentive to shift your behavior.
Because they can't even see what time you did it.
Exactly. The supplier cannot offer you a dynamic time-of-use tariff because their database literally has no mechanism to record what time of day you consume the power. The data simply does not exist in their system.
Which I guess forces the industry mandate you mentioned earlier. Market-wide half-hourly settlement, MHHS.
Yep, they have no choice.
Because to capture that dynamic behavior, smart meters are going to start recording consumption every 30 minutes. But, and I was looking at Saaniya's breakdown here, the sheer volume of data this generates is staggering.
It's a literal tsunami of data.
Yeah. You're taking one integer, like a single yearly estimate, and replacing it with over 17,500 distinct interval readings per year, per meter.
Right. Let's do the math on that. For a mid-sized energy supplier managing, say, 1 million meters.
Okay, so their database goes from holding 1 million consumption records to, ingesting 17.5 billion interval readings annually.
Yeah. 17.5 billion.
That is just wild.
It is. Going from a handful of batch process data points to 17.5 billion near real-time streaming events, it alters the entire topology of an energy supplier's IT infrastructure.
I bet.
It changes database latency requirements, storage costs, integration patterns. I mean, it is an entirely different shape of data.
Okay, but here's where it gets really interesting for me. And maybe I'm playing devil's advocate here, but why does this specific data volume matter to the consumer?
What do you mean?
Well, I look at that 17 billion figure and I think, okay, the utility has a massive new data lake, good for them. But what is the actual value of those specific half-hourly data points to the person living in the house, actually paying the bill?
That's a fair question.
Like, why should you care that the supplier knows exactly what you drew from the grid at 2:30 p.m. on a Tuesday?
What's fascinating here is that we aren't just looking at high-volume data, right? We're looking at high-value, actionable data.
Okay.
Without that half-hourly granularity, a supplier physically cannot mathematically construct an off-peak tariff.
Oh, because they need the proof.
Exactly. If you charge your battery storage system overnight, that half-hourly ping is the empirical proof required for the supplier to bill you at a fraction of the standard rate. So, in a very real way, the data is the currency that buys you a cheaper energy bill.
Gotcha. That makes total sense.
And furthermore, when suppliers aggregate those billions of half-hourly reads across all their customers, their wholesale forecasting becomes exponentially more accurate.
Which means they save money.
Right. They buy power more efficiently, which reduces the massive risk premiums that are currently baked into everyone's monthly bills right now.
Okay. So the data really is the key that unlocks the financial mechanics of a green grid.
It really is.
But that leads directly into this huge architectural bottleneck that Saaniya warns about in her piece. I mean, a legacy billing system designed to just divide one number by 12 is going to violently crash if you try to pump 17 billion microtransactions through it.
Oh, it would be a disaster.
Yeah. You cannot swap a monthly bank statement for a real-time, high-frequency trading ledger without basically ripping out and replacing the underlying software.
Well, and the issue is that legacy infrastructure mostly operates in silos. You typically have this monolithic billing engine, a completely separate CRM for the call center, a totally disparate asset management database for the physical meters.
And none of them are really talking to each other effectively.
Exactly. And maybe another platform handling market messaging. So when you inject billions of new data points into that fragmented architecture, the latency and synchronization errors become catastrophic.
I can only imagine.
You end up with customer service agents looking at screens that just flat out don't reflect the reality of the meter.
And this is where Saaniya's document brings in Salesforce Energy and Utilities Cloud, or EUC.
Yes.
But, okay, I have to push back here for a second.
Go for it.
Salesforce is fundamentally a customer relationship management platform, a CRM. It's built to track, like, sales pipelines, marketing emails, service tickets.
Right.
Settlement math. Calculating the financial liability of gigawatts of power across millions of nodes, that requires massive parallel processing. Are we seriously suggesting a CRM is going to run the complex settlement math for the entire UK power grid?
It sounds crazy when you put it like that.
Right. That sounds like shoehorning a basic sales tool into an ERP's job.
Well, Saaniya actually addresses that misconception head-on in her analysis because you're right, that would be a terrible idea. Salesforce is absolutely not the settlement engine.
Oh.
Yeah, the heavy lifting, the algorithmic math that balances the national ledger that sits with central industry systems like Alexon in the UK.
So what does Salesforce actually do then?
Salesforce EUC is positioned as the vital engagement layer. It sits between those dense mathematical central systems and the human beings who actually need to interact with the service.
Okay, but even as an engagement layer, I still see a massive technical friction point.
Like what?
Well, think about it. If a customer calls the utility complaining about a price spike that happened at 2:00 p.m. yesterday, the customer service agent using Salesforce needs to see that data.
Right, to explain the bill.
Exactly. So is Salesforce natively storing all 17 billion rows of half-hourly consumption data just to render that single screen? Because querying a database that massive while a customer is on hold, I mean, that seems like a latency nightmare.
Yeah, it would be. And that is the exact architectural challenge she highlights. It's why purpose-built industry clouds are necessary instead of vanilla CRMs.
Oh, I see.
Salesforce EUC doesn't replicate and store the entire 17 billion row data lake on its own platform.
Thank goodness.
Right. It utilizes data virtualization and API-led connectivity. It essentially acts as a pane of glass.
The pane of glass, okay.
Yeah, so when the agent opens that customer's profile, Salesforce queries the external data lake or the central settlement repository in real time, but it pulls only the aggregated half-hourly insights relevant to that specific billing period.
Gotcha.
And then it visualizes it. It
Okay.
translates raw mathematical telemetry into a human-readable graph without drowning the CRM's native storage limits.
Okay, that distinction makes a lot of sense. It federates the data rather than hoarding it. And, that actually leads into a specific, deeply technical detail she highlighted about EUC's out-of-the-box industry data model.
Oh, this part is crucial.
Yeah, she noted how it natively handles the relationship between accounts, premises, service points, and assets.
Yeah.
And coming from a generic CRM background, she called this a major revelation.
Well, think about a generic CRM data model. It's built entirely around the account and the contact.
Right, the person.
Yeah. If a company sells software or, I don't know, a pair of shoes, that transaction is tied permanently to the person who bought it. If the person moves to a new city, their purchase history moves with them.
Right, because I am the customer no matter where I live.
Mm-hmm.
But the energy sector operates on a fundamentally different physical reality.
Entirely different.
You essentially have to decouple the human being from the geography.
Precisely. In the utility space, the asset, the physical meter, the heat pump, the solar array, is literally bolted to the house.
Right.
The house has its own distinct energy profile, its own half-hourly consumption history. So if a customer moves out, their financial relationship, their account terminates at that location. But the premise, the service point, and the asset stay exactly where they are.
The digital twin of the house remains intact.
Exactly.
So when the next person moves in, the new account just links to the existing premise.
Yes, and if a supplier tries to build this in a standard vanilla CRM, they have to write a mountain of custom code to force the system to understand that buildings don't move, but people do.
Which sounds incredibly messy.
It is. Saaniya is pointing out that Salesforce EUC understands this multi-layered relational mapping straight out of the box. It inherently knows the difference between a person paying the bill and the copper wire delivering the electrons.
And avoiding that custom configuration must be critical, not just for system stability, but for basic survival. Because, custom code means technical debt.
And technical debt means delays.
Right. And in the context of the MHHS program, delays are fatal. Because, as she lays out, this digital transformation isn't happening on some flexible, whenever we get to it, corporate roadmap.
No, not at all.
The timeline is dictated by rigid industry mandates. According to the document, the central MHHS systems became operational back in September 2025.
Right.
And market migration activities began in October 2025. Now, I'm looking at the calendar right now. Today is July 7th, 2026.
And that timeline is unforgiving.
It's terrifying.
Yeah.
So what does this actually mean for these companies? It means the milestone known as M9, which is the October 2026 deadline for suppliers to be fully MHHS ready to start migrating their customer base, is literally just 3 months away.
Yep.
We are staring down the barrel of a hard regulatory cliff.
And this raises an important question, right? Well, how does a technology delivery team manage a transformation of this magnitude when the deadline is an immovable industry backstop?
I have no idea.
Because in traditional agile software development, scope is fluid. If a sprint falls behind, you descale the feature set or you push the launch date back a quarter. You negotiate with your stakeholders.
But you cannot negotiate with the national grid mandate.
Exactly. October 2026 applies to every supplier in the market simultaneously. You can't just ask the regulator for a 6-month extension because your data migration scripts are throwing a few errors.
Yeah, sorry, our sprint ran long. They don't care.
They don't.
Yeah.
And Saaniya shares the sobering lesson from the front line regarding that reality. Because October 2026 is the readiness deadline, that date is definitively not the development deadline.
Wait, really?
Oh, yeah.
Yeah.
You have to factor in the exhaustive testing required for an initiative of this scale.
Oh, right.
We aren't just talking about internal unit testing. We are talking about market-wide interoperability testing. If one supplier's billing engine calculates half-hourly settlement incorrectly, it creates a financial imbalance in the central ledger that impacts everyone else in the country.
Oh, wow. So the stakes for getting the math wrong are huge. So you have to work backwards from that cliff. If you need to be ready to migrate by October, and you have to prove to the regulator that your system integrates perfectly with the central systems, You need months of dedicated testing before October even hits.
Yes. And then you have the actual data migration.
Which is moving millions of complex relational records, like we talked about with the premises and accounts, from legacy databases into the new EUC data model without losing a single kilowatt-hour of history.
Exactly. So the actual cutoff for writing code, the hard development freeze lands considerably earlier than the public October deadline.
That's intense.
It forces agile development teams into a highly rigid, almost waterfall-like delivery schedule. You aren't estimating effort to determine a launch date. The launch date is set in stone, and the development effort must be ruthlessly prioritized to fit within the shrinking window.
And the crazy part is, even after they hit that October mark, this sprint just turns into a marathon.
Oh, it doesn't stop.
Suppliers then begin the massive process of migrating their actual market participants, a phase that runs all the way to May 2027. Only then, once the entire ecosystem has been completely moved over to the new half-hourly architecture, does the new settlement timetable become fully operational in July 2027.
It is a phenomenal logistical undertaking. I mean, the energy sector is effectively ripping out the foundation of a skyscraper and pouring a brand new one while everyone is still living and working inside the building.
That is a perfect analogy. And it really brings us full circle on this deep dive.
Yeah.
We started out looking at this mundane, monthly estimated electricity bill. Just a piece of paper that relies on the blind guesswork of last year's consumption.
Right, the grocery diet analogy.
Exactly. And to replace that piece of paper, the industry is scaling from a single data point to 17 billion interval readings. They are completely overhauling their architectural layer to handle API-led data federation instead of batch processing.
And deploying sophisticated engagement platforms like Salesforce Energy and Utilities Cloud simply to organize the chaos, maintain that crucial relational integrity of accounts and premises, and actually present actionable insights to you, the end user.
All against a ticking regulatory clock that is just 3 months away. It's wild. The next time you look at an energy dashboard on your phone and it tells you exactly how much power your heat pump used at 3:00 p.m., you can really appreciate the invisible, massive digital ecosystem working frantically behind the scenes to render that one simple graph.
Absolutely. And, there's one more thing to think about here.
Oh, what's that?
If MHHS is establishing the infrastructure to track tens of thousands of data points about your specific habits, we have to consider what happens when that granular data fully integrates with the AI systems increasingly managing our smart homes.
Oh, wow. Yeah.
Right. We are laying the groundwork for a future where your house literally observes wholesale market pricing via its half-hourly connection, autonomously negotiates its own micro tariffs, and shifts the power draw of your appliances minute by minute to generate revenue.
Without you even knowing.
Without you ever lifting a finger or opening an app.
A house that acts as its own autonomous energy trader while you sleep. I mean, that is a wild thought to leave on. Thank you so much for joining us on this deep dive.
Thank you for listening. We'll catch you on the next one.